in Visual Studio as of now, right? So once the infrastructure is set and ready in the Azure console, we're going to go back to Visual Studio, feed these inputs in the Visual Studio so the code knows what the database is, the credentials to log into the database, stuff like that. So we're going to feed those information in Visual Studio. By that, we're actually feeding it into the application, and then we're going to run it from there. Deploying these applications takes quite a while. We really got to be patient. Right, now we have all the resources that we need for the application to run. Here's my database, and here's my app service. There's one more thing we need to do, that is create an firewall exception rule. So one more thing needed is to create an firewall exception rule, right? So the application is going to run from my local desktop, and it's going to connect to the database, right? So let's add an exception rule by simply adding the client IP. It's going to pick my IP, the IP of the laptop I'm using as of now, and it's going to create an exception to access the database. So that's done. Now we can go back to our Visual Studio. I already have a couple of apps running, or a couple of configurations pushed from Visual Studio. I'm going to clean that up. If you're doing it for the first time, you may not need to do this. Alright, so let's start from the scratch. This is very similar to how you would be doing in your environment. Alright, so we're going to select an existing Azure app service. Now before that, I have logged in. As you can see, I have logged in with my credentials. So it's going to pull few things automatically from my Azure account. So in this case, I'm going to use an existing Azure app. So select existing and then click on publish. All right, if you recall, these are the very same resources that we created a while back. All right, we have clicked on save, and it's running, kind of validating the code, and it's going to come up with an URL. Now initially the URL is not going to work because we haven't mapped the application to the database. So that would be the next thing. All right, so the app has been published and it's running from my web app as of now. It's going to throw an error. Like you see, it's throwing an error. That's because we haven't mapped the app and the DB together. So let's do that. All right, let's do that. So let's go to Server Explorer. This is where we're going to see our databases that we have created. Now let's quickly verify that. Go back to the resource group, right? Appropriate resource group, which is right here. And here I have my database, Azure Simply Learn database. Right, it has some issues connecting to my database. Give me a quick moment. Let's fix it. All right, so we'll have to map the database into this application. All right, so let's go to the Solution Explorer, click on Publish, and a page like this gets shown, and from here we can go to Configure. Here is our web app, all right, with all its credentials. Let's validate the connection, number 1. All right, and then click on Next. This is my DB connection string, right, which the app is going to use to connect to my DB. Now, if you recall, our DB was Azure Simply Learn DB, and that's not being shown here. So let's fix that. Right, so let's fix that. Click on Configure, and here let's put our DB servers URL. Now before that, let's change this to SQL Server. All right, and then in here put the DB's URL. So go back to Azure. Here is my DB or server's name. Put that here. Right, the username to connect to the server, that's right here. Put that in, and the password to connect to the server, let's put that in. All right, it's trying to connect to our Azure portal or the Azure infrastructure, and here is my database. If you recall, it's Azure SLDB. That's the name of the database. Let's test the connection. Connection is good. Click on OK. So now it's showing up correctly. Azure Simply Learn DB, that's the name of the database that we created. Now it's configured. All right, let's modify the data connections. Right, let's map it to the appropriate database again. All right, so our name of the database is Azure Simply Learn DB, and then it's going to be SQL Server. That's the data source. The username is Simply Learn, and the password is what we have given in the beginning. All right, let's validate the connection. It's good. Click OK. Now we're all set and ready to publish our application again. Now the application knows how to connect to the database. We have educated it with the correct connection strings, the DNS name, the username, and the password for the application to connect to the database. So Visual Studio is building this project, and once it is up and running, we'll be prompted with an URL to connect, and anytime we put or we give inputs to the URL, that's going to receive the input and save it in the database. Alright, so here is my to-do list app, and I can start creating to-do list for myself. Alright, so I have the items already listed. I can create an entry, and these entries get stored in the database. I can create another entry, take the dog for a walk, that's gonna get stored. I can create another entry, book tickets for a scientific exhibition, and that's going to receive and put that in the database. And that concludes our session. So through this session we saw how I can use Azure services to create a web app and connect that to the DB instance, and how those two services, which are decoupled by default, which are separate by default, how I can use the connection strings to make connection between the app server and the database and be able to create an working app.
So what is Google Cloud Platform? It is a set of cloud computing services provided by Google that runs on the same infrastructure that Google uses to and for its end user products like YouTube, Gmail, and so on. Let's learn about benefits of Google Cloud Platform, such as high productivity, working from anywhere, quick collaboration, high security, fewer data stored on vulnerable devices, reliable resources which can be used across organization, across geographical regions, across countries, very flexible, which allows organizations to scale up and down as the demand rises or as the demand declines, and cost-effective solutions for various use cases. These are some of the benefits. And if we look into different services which Google Cloud Platform offers, we could look into detailed benefits which each service offers in a different use case, which basically helps organizations working in different domains, handling different kind of small, mid, or larger businesses, and with different business goals. When we talk about Google Cloud Platform services, here is a list of services, or I could say high-level domains or categories of services. So you have compute related services, you have storage and database, you have networking, big data, developer tools, identity and security management, Internet of Things, cloud AI, management tools, and also data transfer solutions. When we talk about Google's infrastructure, Google has one of the most powerful infrastructure in the world. The infrastructure is available in two levels, the physical and the abstract layers. You have physical infrastructure and then you have the abstract infrastructure. Physical infrastructure consists of data centers, extensive development of high efficiency backend data centers. You have a very strong backbone network, which is used by Google itself and also offered as services to customers via GCP platform services. So you have global meshed redundant backbone network. Points of presence, when we talk about Google, it has 110 plus edge points of presence in more than 200 countries. And when we talk about edge caching platform at periphery of their network. So this is what defines the physical infrastructure of Google. Now there is much more to it rather than just these 4 points. When we talk about abstract infrastructure, that is divided in global, regions, and zones. When we talk about zone, a zone is roughly equivalent to a data center and a single point of failure. So you could have your compute engine, which is within a zone, or you could say compute engine is a zonal resource. You have regions, which are geographical areas which contain multiple zones. So you could have a region for US Central or Europe Central, Europe West, and so on. And within a region, you would have one or multiple zones, and zones basically would allow high availability of resources. So you have cloud load balancer as an example, which is regional resource. Then you have global resources, and they are available and shared across the planet. So you have various global resources such as network, which could be even your IP addresses and so on. Now let's do a quick comparison of AWS vs Azure vs GCP, and let's look at what each cloud provider offers. Later we will also look into different services in detail when it comes to Google Cloud Platform, what each service does, what you can benefit from, which service should you use in what case. We will learn about those in later slides. If I compare your different cloud providers, when we talk about Amazon and its cloud offerings, that is Amazon Web Services or AWS as we well know it. Amazon Web Services has 69 availability zones within 22 geographical locations, and soon it will have 12 more in future. So this number keeps growing based on the spread of the services which a particular cloud provider offers. Here we are talking about availability zone specific information. When we talk about Microsoft's Azure, it has 54 regions worldwide and is available in 140 countries across the globe. When we talk about Google Cloud Platform is available in 200 plus countries across the globe. When we talk about virtual servers, Amazon's EC2, that is Elastic Compute Cloud, it is a web service which basically helps to resize your compute capacity, where you can run your application programs on a virtual machine. So using EC2 service, you could launch virtual instances that could have any distribution of Linux, Windows. You could have different specifications when it comes to RAM or CPU cores or disk. You could also decide on what kind of storage a particular instance should use, whether the storage should be local to the instance or whether that should be an elastic file system or even an object storage. When it comes to Azure or Microsoft's offering, Azure Virtual Machine, that is infrastructure as a service, gives a user the ability to deploy and manage a virtual environment inside a virtual network on the cloud. And this virtual network on the cloud would be managed by cloud provider. Google Cloud, or the offerings from Google Cloud Platform, that is GCP VM instances, enables users to build, deploy, and manage virtual machines in order to run different kind of workloads on the cloud. Now, when we talk about compute engine, here it would be good to discuss a little bit more about compute engine and what are the different options which Google Cloud offers. So when you talk about your compute engine, you have scalable, high-performance virtual machines. Compute Engine delivers configurable virtual machines which run in Google's data center with access to high-performance networking infrastructure and block storage. And you could select VMs for your needs. That could be general purpose or workload optimized. And when we talk about workload optimized, you have predefined machines or you have custom machine sizes. You can integrate compute with other Google Cloud services such as AI or ML and go for your data analytics. You have, when we talk about your GCP VM instances, just to expand on that, you have general purpose instances, which we call as N2, which provide a balance between price and performance, and they are well suited for most workloads, including line of business applications, web servers, and databases. Google Cloud also offers compute optimized instances, which we call as C2 instances, which offer consistent high-end virtual CPU performance, which are good for AAA gaming, EDA, HPC, and other applications. Now, when we talk about compute optimized or general purpose, how would we leave memory optimized instances? Those are M2 machines, which Google offers. So these offer highest amount of memory. These VMs are well suited for in-memory databases such as SAP HANA, real-time analytics, and in-memory caches. So if I would summarize this, when we talk about different instances, AWS also offers different kind of instances which are memory or compute or disk optimized. You have general purpose, and each category of machines has a different pricing model. You can always go to an AWS website, look for the pricing models, and that will give you an idea of on-demand instances or dedicated instances, reserved instances, and so on. Similarly, if you talk about Google Cloud also has instances with various options, which become the key features of why customers would choose Google Cloud Platform, such as live migration for VMs. So Compute Engine within your GCP can live migrate between host systems. And when I say live migrate, it basically means without rebooting, which keeps your application running even when the underlying host systems require maintenance. You also have preemptible virtual machines, wherein you can run batch jobs and fault-tolerant workloads on preemptible VMs to reduce your virtual CPU and memory cost by up to 80% while getting the same performance. So these are your preemptive or preemptible virtual machines. The only demerit is these can give you a really cost efficient resource usage, however, can be taken off the shelf anytime. And that's why we call them preemptible virtual machines. You also have sole tenant nodes, which are physical compute engine servers dedicated explicitly or exclusively for users' use case. And when we talk about sole tenant nodes, these are usually good when you are dealing with or when you're working with your applications, which we call as bring your own license applications. So sole tenant nodes give you access to same machine types and virtual machine config options as regular compute instances. So there are different options which Google Cloud offers when it comes to these instances which we are talking about, and it takes care of different use cases in comparison to other cloud providers which are also offering these services, such as you can have predefined machine types, you can have custom machine types, preemptible VMs, as I said, live migration of VMs, you can use persistent disks, which could give you durable high performance block storage. You have local SSDs. You also have GPU accelerators, which can be added to accelerate computational intensive workloads such as machine learning, simulation, medical analysis, and so on. And you have features such as global load balancing, which makes Google Cloud a unique choice. When we talk about platform as a service, Amazon has platform as a service offering, which we call as Elastic Beanstalk. Among one of its services, it's an orchestration service for deploying applications and helping in maintaining these applications. Azure Cloud Service provides a platform to write the user application code without worrying about the hardware resources. Google App Engine is a service used by developers for building and hosting applications on Google's data centers. When we talk about serverless computing, so Amazon's AWS Lambda is a serverless compute service. It is used to execute backend code and scales automatically when required. When we talk about Azure, you have something called as functions, which allow users to build applications using serverless simple functions with a programming language of their choice. When we talk about Google Cloud, GCP has cloud functions, which is easiest way to run your code in the cloud, and it is highly available and fault tolerant. So in these days, when we are talking about microservices architecture, which organizations are preferring, when we are talking about organizations which can scale, which can dynamically change their underlying architecture, organizations would be interested in serverless computing, where they do not have to have a infrastructure set up, planned in advance before going for their use case. And this is where monolithic applications are really not a preferred choice. A lot of organizations are decomposing their applications into microservices based on business capability or decomposing based on subdomains. We can learn about microservices architecture later, but just to know that serverless computing, which basically helps any organization, if, for example, if you have a web application that receives non-linear traffic and you cannot keep an eye on your server always, it would be good to have someone to auto scale your application. Serverless is basically a computing model where cloud service provider is responsible for managing the piece of code without the developer having to bother about infrastructure setup, management, maintenance, and so on. Now, when we talk about applications being serverless or benefiting from serverless computing, one of the key things would be zero administration, so deploying application without any provisioning and management. auto scaling capability, that is, let the service provider worry about scaling the application up and down. You have pay-per-use model, which any customer would want to benefit from, that is, pay only for the resources that you have used or that you are continuing to use, right? Shorten the time between idea implementation and deployment, and this is something which any organization would want, that you would want a faster bring to the market solution timeline in comparison to getting entangled with deployment, management, and maintenance of your underlying infrastructure when your applications are facing a high demand. So when we talk about serverless, it is a function as a service, because each part of your application is divided as functions and can be hosted over multiple service providers. You have serverless apps, which are usually divided as separate units or functions based on functionalities or domains and so on. So serverless computing is gaining quite popularity these days in comparison to the traditional three-tier architecture, where you had a presentation layer, you had an application layer, you had a database layer. Now that kind of infrastructure is not really preferred in today's modern times when organizations are working on different kind of newer applications. When we talk about object storage, Amazon has simple storage service, that is S3. It provides object storage, which is built for storing and recovering information or data from anywhere over the internet. Azure comes up with blob storage, that is binary large objects storage, offers large amount of storage and scalability. It stores the object in the tiers and depending on how often the data is being accessed. Now same thing applies to even S3, which is from Amazon. So S3 also has different kind of storage classes which can be selected when a user or an organization intends to use a storage service. And when I speak about storage classes, it basically means having a frequent access storage or a infrequent access storage, or what we call as just an archival solution. Google Cloud has cloud storage, and it provides unified object storage for live or archive data. This service is used to store and access data on GCP infrastructure. When it comes to advantages, Amazon Web Services has enterprise-friendly services, easy access to resources, increase in speed and agility, and that too on demand, and takes care of your security and reliability of resources which are offered. When it comes to Azure, it has better development operations, strong security profile, provides a lot of cost-effective solutions, and operation execution friendly. When we talk about Google Cloud, one of the key features here is better pricing than competitors, live migration of virtual machines, which really interests a lot of organizations would want to modernize their infrastructure without having any kind of disruption in their existing services, improved performance, redundant backups, and so on. When it comes to disadvantages, in AWS, you have limitations when it comes to EC2 service. Well, there are different options in the kind of machines which you can choose, which you can work on. You have a technical support fee, which is incurred, network connectivity, and then also downtime, which might be in case when you're migrating. Azure, it has different code base for cloud and premise. Platform as a service ecosystem is not really as efficient as infrastructure as a service. Poor management of GUI and tools, integrated backup. When we talk about Google Cloud, support fee is quite hefty. It depends on what kind of solution or support you would or organization would be interested in. It has a complex pricing schema, although it has different use cases for which any user or any organization can benefit from. Downloading data from Google Cloud services is an expensive option. Storage might not be. However, uploading data or downloading data would be an expensive option. When we talk about Domino's Pizza use case, now while we were discussing about these features, I would really want to spend more time in discussing each of these features or services in detail, such as you have compute engine, you have storage, you have big table, you have data proc, and so on. So there are a huge list of services. Now, before we get into your Domino's Pizza use case, let me show you this page on Google Cloud where you can look at different services. So if you go to cloud.google.com and if you look at get started option under docs, so here you can find build solutions, look at different use cases, learn from basics of what is your Google Cloud, what are cloud basics. Then you can look at different cloud products. So here you have products in different categories such as AI and machine learning, API management, compute, containers, data analytics, databases, developer tools, and so on. And you can always click on any one of these to look into different solutions which are being offered, what are the different use cases, what are the best practices when it comes to migrating VMs to compute engine or operating containers or building containers and so on. You can always look at featured products, and that gives you a quick snapshot of what are the different products, such as you have compute engine, you have cloud run, BigQuery, which is a data warehouse, you have cloud SQL, which is a managed MySQL or Postgres, you have cloud storage to basically push in any kind of data there, you have security key enforcement, AI and machine learning, and so on. So you have different featured products. Now if you scroll down to the lower end of this page, you can again look at different solutions, and that would be really interesting to read and learn from. So you have infrastructure modernization, you have application modernization, you have data management, and so on. So if I look at infrastructure modernization, you could basically look at the solutions which Google Cloud offers and what it does when it comes to having your infrastructure modernized or benefiting by integrating with cloud and having immediate benefits of infrastructure modernization. You can look at different use cases, what they are doing, how Google Cloud really helps when it comes to migrating the workloads to a cloud, and how your different cloud solutions such as VM migration, you have SAP on Google Cloud, VMware as a service, and so on. And you could learn from these different solutions which are offered. You can also look at application modernization. So not only infrastructure modernization, but organizations would also be interested in relooking at their applications, relooking at how these applications could be moved from monolithic to microservices architecture, or how applications can benefit from modernization and cloud computing offerings. So you have again different use cases here, uh, which talks about different ways in which Google Cloud can help, how you can modernize your applications, how you can use different solutions which Google Cloud is offering. Now, when we talk about cloud computing services, you can always go into cloud.google.com. If you have created a free account, then you can just log in, and every user by default gets a $300 free credit, so wherein they can try out different products, where they can use different services. So here, if I click on console, where I'm already logged in with my Gmail account or my Google Cloud account, wherein I have $300 free credit, out of which some is being used. You have a Google Cloud console, and here from the hamburger menu, you can click and you can look at different services within different domains. So you have compute domain, which has different services such as app. You have compute engine, and that basically allows you to use your VM instances, which we were talking about previous slides, different instance groups, create your templates, use sole tenant nodes, create snapshots or backup of your data, use different zones. You can go for Kubernetes, which is containerized based engine. You have cloud functions, you have cloud run, and then you have storage related different options such as big table, you have data store, firestore, file store, storage, and so on. And for each of these services, you can read about from the Google's documentation, or anyways, I will be explaining that later. You can also look at networking related, operation related, and other tools which are offered by Google Cloud. So these are huge list of services which Google Cloud Platform offers in different ways for different use cases. Now, let's look at this Domino's Pizza use case and see what it helps us learn about. So you can always access this page by going to this link which talks about customers and then which shows you different use cases. So Domino's increasing monthly revenue by 6% with Google Analytics Premium, Google Tag Manager, and Google BigQuery. So this is basically when Domino's started using GCP and what was the result of that. Now let's look further into this. So we all know that Domino is most popular pizza delivery chain operating across the globe. But how was that possible? Let's take a look. So the challenges were they wanted to integrate marketing measurement across various devices, connecting CRM and digital data to create a clear view of customer behavior, to make cross-channel marketing performance analysis easy and efficient. Now, for these challenges which Domino's was facing, the solution was using Google Analytics Premium, Google Tag Manager, and BigQuery, which were used to integrate digital data sources and CRM data. Reporting was made easier and more efficient by implementing Google Analytics Premium because it had the ability to access a single Google Analytics account to evaluate web and app performance. By using the new Google Tag Manager implementation, Domino's were able to act fast. They were able to connect CRM data with digital analytics, which basically provided Domino with greater visibility on customer behavior. What was the result? There was an immediate 6% increase in monthly revenue, 80% of costs in ad serving and operations were saved, increases agility with streamlined tag management. They obtained easy access to powerful reporting and customized dashboards. Now that was just one simple use case. Before we go on to hands-on, we can also talk a little bit back about the services which Google Cloud offers, as we discussed, and some of these services which can really make you think, why not Google Cloud Platform? So when we talk about your different cloud platform services, let's learn about some of these services in brief, in what each service is, what it does, and how it can help us in handling our use cases or working with different products. So let's learn briefly about different services which Google Cloud Platform offers. Now, one of the domains is compute, and then let's look at the compute services which GCP offers. Now here I can log into the console, and this hamburger menu on the top left corner, I can click on this one and go into the compute engine section. So this is the compute domain, which has app engine, Kubernetes engine, cloud functions, and cloud run. So these are your different services which are offered within the compute domain. And here we can get into compute engine by clicking on this one and then basically going to VM instances. So before we see how we can use this compute engine, let's understand about some of the features of compute engine, which basically offers scalable, high performance virtual machines, which are configurable and which runs in Google's data center with access to high performance networking infrastructure and block storage. So from here, you can select VM for your needs, for your general purpose or workload optimized, predefined or custom machines. Now here you can integrate compute with other Google Cloud services such as AI, ML, and other data analytics services. You have different machines which are offered here, such as general purpose, which provide a balance between price and performance, which are well suited for most workloads, including line of business applications, web services, and databases. You also have compute optimized machines, which offer consistent high-end virtual CPU core performance and which are mainly good for gaming, EDA, high process computing, and other such applications. Apart from general purpose compute optimized, you also have memory optimized machines which offer highest amount of memory. And these VMs are basically well suited for in-memory databases such as SAP HANA, real-time analytics, and in-memory cache. Now, we can see these options here. You can click on VM instances while you're logged in into your Google Cloud Console. Here, you can even create an instance template which can be used to spin up instances. For example, if I click on new VM instance from a template, there are some templates which I have already created for my usage. Now here, I can basically use one of these templates, or what I can do is I can go back, I can go into instance templates, and this basically allows me to create a template. So you can click on create instance template, which basically allows you to create templates which can be used to spin up different instances. We can give a name to the template. For example, we can say template instance. Now here I can choose machine configurations, and this is where you have different options. So you have general purpose, as I mentioned, which provide a balance between price and performance. You have memory optimized, which are large memory machine types for memory intensive workloads. You also have compute optimized, which basically give you high performance machine types for compute intensive workloads. So you can choose any machine configuration which is available here based on your requirements. Now, if you click on general purpose, that has different options here. So you look into the series where you have N1 series, you have E2, which are CPU platform selection based on availability. You have N2 and N2D. So let's just have N1 selected. Now, you also have here, which talks about machine types. And here we can choose the configuration which we are interested in. Depending on the applications which will run within the machines, we can choose a machine. So by default, it shows one virtual CPU core and 3.5 gigabyte of memory or RAM. You could choose a higher end machine. So as of now, I'll just say N1 standard. Now that basically allows me to choose these machines. So there are different features which your compute offers, such as you have live migration for VMs, you have preemptible virtual machines, you have sole tenant nodes, and all those options can be seen here. Now in this machine, for my boot disk, I can select a distribution which I would be interested in. For example, I could be going for public images, and I can choose, for example, Ubuntu. And then I can choose a version. So it shows me 16.04. And you also have latest versions such as Ubuntu 20. You can choose one of these. And here it asks you to choose the boot disk type. So that could be standard persistent disk, which is HDDs, which are low in performance and you can say low in cost in comparison to SSDs. So SSDs give you better performance, but then they are a little expensive than using standard persistent disk. We can choose this and we can give a disk size, for example, 20 gigabyte, and I can click on select. Before clicking on select, I can click on custom images, and that shows me if you have any other images created in your project, you could use those. You could also learn about images by clicking on this link. So we'll click on public images. We have chosen this distribution. Let's do a select. And now here you have identity and API access management. So let this be default. You can say allow default access. And what you need is, depending on the services, we can choose it allows HTTP and HTTPS traffic. Now, we would also need some way to connect to these machines. So when you set up an instance, by default, you can do SSH into it using the Google Cloud Console or from Cloud Shell. You can also give a private and a public key. So here you have the option where you can give all these details. So when it comes to management, it tells you would you want to go for reservations, and you can say automatically use created reservation. You could also say no, you would not want to use a reservation. You can also set up or provide a startup script which you would want to give whenever your machines come up. And here you have the options of preemptibility. So compute offers preemptible virtual machines. So that is mainly when you would want to run batch jobs and fault tolerant workloads on these machines, and you can benefit with a reduced cost for your virtual CPU and memory by 80%. So these are virtual machines which would be lasting less than 24 hours. Now by default this is off, and it purely depends on your workload, what you would want to run on these instances. I could just go ahead and select preemptible being on that and use this feature of compute. You also have on host maintenance, which talks about what would be happening with this compute engine instance. So when compute engine performs periodic infrastructure maintenance, it can migrate your VM instances to other hardware. And this is one of the features which compute engine offers, which we call as live migration for VMs. Here, your compute engine can live migrate between host systems, that is the underlying systems on which these VM instances are based on, without rebooting, which will keep your application running even when host system require maintenance. And here it says migrate VM instance recommended, and let that be as it is. You can also say that if there is a maintenance happening, you can terminate the VM instance. Now, it also talks about automatic restart, which is on, which basically means compute engine can automatically restart VM instances if they are terminated from non-user initiated reasons. So these are all the settings which are available in management, and it also tells us the different features which we have. There is also a feature called sole tenancy, which basically means sole tenant nodes which can be chosen. So you can have physical compute engine servers dedicated exclusively for your use, and this is usually good when you're talking about bring your own license applications. So sole tenant nodes give you access to same machine types and VM configuration options as regular compute instances. However, these might be a little expensive. We can choose this one. We can also look into networking, which basically shows the default setup, which goes for auto subnet. You can also choose a particular IP if that is required, but that would cost more. You can click on disks, which talk about what do you want to do with the boot disk when the instance is deleted, what is the encryption mechanism you would want to use. And here, finally, you have security. So basically, as I said, you can SSH into instance using the Cloud Console option, and you can also provide a public SSH key. So one way of doing that, if you intend to use an external SSH client such as PuTTY to connect, you can create a key. So for example, I can go into PuTTY Gen, and here I can say generate, just move my cursor over here, and that will create a key. I can give a name to this one. So I'll say SDU will be username. I'll give a simple password, which I will use to log in to this machine. And then I can save this private key, which will get saved. So let's say SDU new key, and this gets saved in a .ppk file, which is usually used when you use an external SSH client to connect. So save this one, and that saves a ppk file on your desktop. What you can also do is you can copy this public key content from here, and this is what we would want to give in our instance here. So that the public key gets stored on the instance, and private key is what we will use to connect. So once I paste it here, it resolves the name to HDU, and we have given the public key. Now in certain cases, you may want to use a software which uses SSH to connect to the machine, and that software might not be such as your PuTTY. So in that case, you may want a PEM file or a private key which is saved as a .pem file. So you can also do that by going to conversions and do a export OpenSSH key and then save it. So I'll say HDU new key, but then this one will be saved as a PEM file on my machine. So you have ppk file, which allows you to use PuTTY to connect to the instance. You have a PEM in case a software needs directly SSH to these machines. You also have the public key, which we have already provided in the machine. Now, once this is done, I can close PuTTY Gen. I can go back to this page where I'm creating an instance template, and then I can just click on create. So this has created an instance template, which I can use to spin up my instances, any number of instances using the same template. Only thing which I would have to do is change the region where I would want the instance to run. So now that we have created instance, and that's this one, the third option, I can go back to VM instances. Now I can click on create, and here I can either create an instance from scratch by giving all the details again, or I can just use my template. So I can click on new VM instance from a template, choose my template, click on continue. And once this is done, I can give my instance name. So let's say C1. I can choose the region. So I will choose Frankfurt, and then rest everything is auto populated based on the template what you have given, and you click on create. Now this basically allows you to spin up an instance, and you can create any number of instances using your template. You could have already created a new instance right from scratch. Now once the instance is created, this has a public IP and a private IP. Private IP will not change unless you would want to set up a new machine, but public IP will change every time you stop and start the machine. Now this is what we need to connect to this machine. I can also do a SSH from here by doing this and open in a browser window. Let's click on this. So this is an internal way of connecting to your instance using SSH. Let's wait, because it would be transferring the SSH keys to the VM. It establishes a connection and I'm connected to my machine. What we can easily do is to confirm if we are in the right machine. We can just do a ls to look at the file system. What we can also do is we can basically log in as root by doing a sudo su, and that allows you to get into the machine as root. And from here I can switch to HDU user, which will have a .ssh directory in home, and that basically has authorized keys. And if we would want to see if this one contains my public key, I can just do a cat.ssh and then look into authorized keys, and this shows me the public key which we had initially added to our instance. So this confirms that we are logged into the machine which we created. Now I can close this, and what I can also do is I can copy this public IP. So let's do a copy to clipboard. Now go to putty, and here I will say hostname, where I'll say HDU, give my public key. I'll click on SSH, and in SSH I'll go to authentication. Now here we need to give our PPK file. So the PPK file was HDU new key. Select this one, come back here, come to the session, give it a name, for example C1, save it, and then you can just say open and say yes, and you are logged in to your machine. Now once you're logged in, you can always do a -SSH, and that shows you the file. So this is how you have just used the compute engine to spin up an instance, but we used a template which basically allowed me to create this instance, and then I can connect to this instance, and then I can start working on this. So when we talk about features of compute engine, it has predefined machine types as we saw. So compute engine offers different predefined virtual machines, and they have configurations for every need, from small general purpose instances to large memory optimized instances with up to 11.5 terabytes of RAM. You can have fast compute instances optimized up to 60 virtual CPU cores. You also have custom machine types, so you can create a VM that best fits your workload, and by tailoring a custom machine type to your specific need, you can realize significant savings. There are preemptible VMs, which we saw. There is also a facility which allows you to take the benefit of live migration. For VMs, you have durable high performance block storage for virtual machine instances in the form of persistent disks, where data is stored redundantly for integrity, flexibility, and to resize storage without interruption. And you could be choosing HDDs or SDDs for your instances. Now you also have options such as GPU accelerators. So for example, if I just click on create instance, and I can look into that. So here, let the instance name be instance 1. And what I would be interested in looking at this one, which says CPU platform and GPU. So CPU platform configuration is permanent. You can also do add GPU. So GPUs can be added to accelerate computationally intensive workloads like machine learning, simulation, medical analysis, and virtual workstation applications. So you can add and remove GPUs to a VM when your workload changes, and pay for GPU only while using. So these are some of the features which basically compute engine offers, and we already know that Google bills in second level increments, so we only pay for the compute time. Now there are different savings which are possible. So you have commitment savings, which basically means you can save up to 57% with upfront cost per instance type lock-in. You have container support, so you can basically run, manage, and orchestrate Docker containers or compute engine instances. So here, when we are setting up our instances, there is an option which basically allows you to use or deploy Docker images. Now that can be done. You can also benefit from sustained use savings, that is sustained use discounts, which are automatic discounts for running compute engine resources for significant portion of the billing month. You can create a reservation for VM instance in a specific zone, which is basically seen under your management section here, and you can ensure your project has resources for future increases in demand, and if no longer needed, delete the reservation. So these are some of the features of Compute Engine. What we have done is we have created Compute Engine using the console. Now you can go back. You can also do that using Cloud Shell, and you can click on this one, which activates Cloud Shell. You could also have the Cloud SDK support set up on your machine, which can be used. Now I can just open this in a new window, and from here I can start giving commands if I would be interested in setting up an instance from my command line. So here you have different options. Now to begin with, you can just do a G Cloud and just hit enter, and that will show you different options which are available, which can be used. So you have G Cloud Compute here, which shows an option to create and manipulate compute engine resources. Now I can just do a Q to quit. I can do G Cloud Compute, and that basically will again show me different options which are available if you would be interested in setting up instances from the command line. So here I can say G Cloud Compute and then go for instances. And if you do not know the commands, you can just hit enter. That will show you all the different options which we have. So here we have different options such as list or create or start or update. For example, I can just do a list here to see what instances I have. And the instance which we just created shows up here. It says that status is running. I can just stop this instance. I can delete this instance. I can even create an instance by using a create command here, and you can just do a create help, which will show you what are the different options you can give. So it says instance name is what you need. You can choose an accelerator, you can choose the boot disk, and various other options. So I can just say create, and then I can give a name, for example C2, and once I click on this one, it says, did you mean Europe West 4 zone? So it is asking me for the region and the zone, and I can say yes. And these settings are coming from my default profile. I can always change those by changing the metadata. So now we have created an instance. It says running. If we do a list again to see, we see two instances created. One was in Europe West 3, one was in Europe West 4. Both of them have internal and external IPs. Now you can do a describe to look at the different options here. So G Cloud basically allows you different commands which you can use to work with your instance, to create instances, to change the metadata. If you would want to change the region, if you would want to add a startup script, all those options are possible from the command line, which we can learn in detail in later sessions. So this is your compute engine as a service. Now that we have learned about the compute domain and compute services, which is offered by GCP, let's also learn about storage and databases. That's again within the storage domain and the services which are offered by Google Cloud Platform. Now you can go back to console, and here you can click on this one. And here you can just scroll down to see what are the different options in storage. So you have options such as Bigtable, you have data store, Firestore, file store, you have SQL based services, you have storage, which is object storage, and then you have other options which are available. So Google Cloud Platform offers different storage based services, out of which storage, which is your object storage, is quite popular one. Click on storage, and that basically shows you an option which talks about storage browser. So this is your Google Cloud's object storage. So when we talk about object storage, it is basically a storage where you could store any kind of data. And when we talk about object storage, it is a bunch of bytes which we address, wherein every object will have a unique key. These unique keys are in the form of URL, which allows you to access the object. So cloud storage is comprised of what we call as buckets, which are used to store and hold your storage objects. These storage objects are immutable, and every change creates a new version. Now you can also have control access via IAM, that is Identity Access Management, or via Access Control List. So there is also an option called object versioning, which basically says if it is on, every time you try to store the same object, a new version of the object would be created. Otherwise, newer option will override old one, as we cannot archive the old version. So let's see how we work with this object storage. So here you can click on create bucket. Now once you click on create bucket, it needs a name. So let's say test bucket. And here I can just give, say, number 1. So that says this is the name of my bucket. Now I can directly click on continue, or it would be good to look at different options which are available here. So when you click on choose where to store your data, so it already gives me an option. It says the bucket name is already taken. So let me give it a unique name. So let's say test buck, and let's call it AUA. So that should be unique. Now here it says choose where to store your data. So this one gives you location type. So you can have region specific buckets which give you lowest latency, that is fastest response time within a single region. However, it does not make your storage highly available. You can make it dual region, which is basically allowing your bucket or storage to be accessible across regions. You can also make it multi-region, which is highest availability offered. As of now, we can choose region specific, and now it asks you to choose a location. Now, as always, I will choose Frankfurt. Now I can click on continue and let all the storage options be default, or you can click on a default storage class. Now that tells you based on your storage class, there are variant costs when it comes to storing, retrieving, or doing any kind of operations. So you have a standard option which says best for short-term storage and frequently accessed data. You can also go for cold storage such as nearline, which is best for backups and data access less than once a month. You can go for freezing storage such as cold line, best for disaster recovery and data accessed less than once a quarter. Or you can go for archiving, where the data is accessed less than once a year. Let's go for standard as of now. And now you can choose how to control access to objects. So you have fine-grained or uniform. Let it be fine-grained, wherein you can give additional permissions at bucket level using IAM, or object level permissions using access control list. In advanced settings, you can choose the encryption, and you can also choose a retention policy. So a retention policy to specify the minimum duration that this bucket's objects must be protected from deletion or modification after they are uploaded. You can always learn about this more by clicking here. Now, once I've chosen all the relevant options, I can click on create, and that basically will create a bucket by the name I have given. I can click on overview to basically see brief details about my bucket, such as region, what is the default storage class, and it also shows you the link URL, which can be used to access your bucket. It also gives you the link for gsutil. Now gsutil is a command which can be used in your Cloud Shell to basically work with your buckets. You can click on permissions to basically see what kind of permissions are already in place, and you can then make changes. You can basically add members. You can view by different roles. So for example, here by default it shows other services such as data proc or your bucket owner or bucket reader related permissions which have been already granted. Now, once I've looked at my bucket, I can start using it. I can drag and drop and push in files here. So as of now, there are no live objects in my object storage that is in my bucket, what I can do is I can click on upload files, and then I can choose a location from my machine. For example, I'll go into data sets, and what I can do is I can choose some of the files here in any format. Let's choose CSV or text and just to open. So this one will basically upload my data sets here. Now, once I've uploaded the files, I can basically close this one. I can look into options here which says edit permissions, edit metadata. If you would want to download it, if you would want to copy, move, or rename it, if you would want to export to a different service called Cloud Pub Sub, which is Publish Subscribing Messaging System, you can scan the data. Now you can click on a particular file, and that basically shows you the URL, which basically allows you to access this file. You can try copying this. You can click on download and download this file. You can even try accessing this from public, and that basically shows you the content of this file based on the permissions. So this is basically your object storage, which is one of the service which is offered. What you can also do is you can create folders, and within folders you can then upload your data. So this is your Google Cloud storage option, which is for your object storage. That is, you can add different items, you can give different permissions, and you can use this Google Cloud Platform's storage service offering. Now you also have other options such as Bigtable, and we can go into that by clicking here and click on Bigtable. So Bigtable is one of the service which kickstarted NoSQL databases. Today in market, we see different NoSQL databases such as Cassandra, HBase, MongoDB, CouchDB, Neo4j, and many others. So you can basically use Bigtable, which was the pioneer when it comes to your NoSQL databases, or not only SQL databases. So the problem initially faced by Google was that the web indexes behind search engine were taking too long to build. So company wanted to build database that would provide real-time access to petabytes of data. And that's where Bigtable began. So Bigtable powers different other Google services such as Gmail, Google Maps, and other services. And in 2015, it was launched as a service for customers. So when it comes to scalability, with use of Bigtable, you can increase your machine count without any downtime, and you can handle admin tasks like upgrades, restarts, and so on, which are basically taken care by the cloud provider. Data present in Cloud Bigtable is encrypted, and you can use IAM roles to specify access. So data written to or from Bigtable is through data service layers such as managed virtual machines, HBase REST servers, Java services, HBase client, and so on. Here, if I would want to use Bigtable, I can click on Create Instance, and that basically tells me Cloud Bigtable Instance is a container for your clusters. Now here you can give an instance name. So for example, I will say AUA and then say, for example, test, and let's say Bigtable. So that will be the name of instance. This will be permanent. You can choose the storage type. Again, you can go for lower latency, more rows read per second, typically used for real-time serving use cases, or you can go for SDDs, which have higher latency for random reads, good performance on scans, and typically used for batch analytics. So let's go for SSDs as of now. Here you have cluster ID, which is auto-populated. You can choose a region. So let's go for our favorite one here, where I can say Europe West 3. I can choose a zone here, and I can then choose how many nodes would I want to use for my Bigtable. So when you talk about Bigtable service, it will have a cluster underlying, which will have various nodes, which will control your data throughput, storage, and rows read per second. So as of now, let it be just one node, and that's enough for our demo. When we talk about performance, it basically tells you based on the current node and storage type, it tells you how many reads can happen at milliseconds. So it says 10,000 rows per second at 6 milliseconds. You have writes, which are 10,000 rows per second, or you have scans which are 220 megabytes per second. Storage which is taken care here would be 2.5 terabytes, and I can then basically click on create. Now there is also some option called replication guidance, which basically says replication for cloud table big table copies your data across multiple regions, enabling you to isolate workload and increase the availability and durability of your data. Depending on your use case, you can have big table which can be used to have your data across regions. Now you can click on create with all your specifications chosen, and that's going to set up a cluster, or you can say a fully managed NoSQL database, which will give you low latency and replication for high availability. Now, once we have a new instance, you can connect to it with the CBT command line tool. And for instructions, you can click on learn more here. You can just click on this instance ID to see the details again if you would want to look into your big table setup. So it tells me here that we have one instance, what is the CPU utilization time, how many rows were read or written, what is the throughput, and this is auto-populated based on your usage. You can click on monitoring, and that basically will give you different widgets which will display information for your CPU utilization, what is your hottest node, depending on how many nodes you have, system errors, automatic failovers, storage utilization, and so on. You can click on Key Visualizer, which will allow you to look into your table if you have already created some data here, and you can click on tables to see how many tables you have added here. So that's in brief about your big tables, which is one thing which we need to remember is it's not good for all use cases. So should be used for low latency access, that is fast access, and good if at least data is greater than 1 terabyte. For smaller amount of data, the overhead is too high. So big tables performance will suffer if you store individual elements larger than 10 megabytes. If you want to store bigger objects such as images, video files, then go for object storage, and that would be a better option. So always remember, big table is not a relational database, it's a NoSQL database. And when you talk about multi-row transactions or online transaction processing, big table is not the right choice. So it can be used for wide range of applications, especially when you talk about your OLAP, that is online analytical processing. So it is designed to store key value pairs, and there can be different use cases. So for example, if you're using something like Cloud Data Flow or Cloud Data Proc, where you would want MapReduce kind of operations, big table can act as a good storage because it has very high throughput and scalability. And the best thing is that it supports HBase API, thus allowing easy integration with Apache, Hadoop, and Spark clusters, which you can bring up using one more service which Google Cloud Platform offers, which is called Cloud Data Proc. So big table is good for real-time analytics. It's commonly seen in financial services, IoT, and others. And if you are thinking of running interactive SQL, then big table would not be the right choice, but the other choice would be BigQuery. You should also remember that this has a cluster running, and you would be charged if this cluster kept on running. So you have to be very careful in your free account when you're using such services. Now we have clicked on this one, so I can select this one, and basically I can look at the permissions, I can look at the labels, I can look at inherited permissions here. I can also click on my instance which we created, and either you can edit or you can just do a delete. So as of now, we will just delete this, which needs you to give in the name. So we'll say AUA test BT and then click on delete. So whenever you're trying out different services, the first approach should be setting up these different services, seeing how they work, basically trying connecting to them. And once you are satisfied with the initial test, then you can plan your actions and come back and use the service for a longer duration. Now that's your big table, which is one of the offerings. We can go back into storage, and here you have other options which are available. So for example, we were in big table. You also have an option such as Cloud Data Store. Now that's one more service which is offered by Google Cloud Platform when it comes to storage domain. So Google added software on top of Bigtable which supports more than simple key value pairs. When you talk about secondary indexes, instead of just having one primary index, when you talk about asset properties for reliable transactions such as SQL query like language, so these features or these services were added to or on top of your Bigtable, which gave birth to a new service which was released as Cloud Data Store. So this is where you have Cloud Data Store and you can select a Cloud Firestore mode. So you can go for a native mode, enable all Cloud Firestore's features with offline support, or you can go for Cloud's data store system on top of Cloud's Firestore. So these are different options here. And here we look at the API or scalability, engine support, how many writes it supports, and so on. You can choose one of these and then you can choose where to store your data. So for example, if I click on this one, then it asks me to choose a location. So it says the location of your database affect its cost, availability, and durability. Choose a regional location, lower write latency, lower cost, or multi-region location. Here I can basically choose, for example, Europe, and then I can go ahead and create a database. So it says initializing Cloud Firestore in data store mode services in EU3. This usually takes a few minutes. You'll be redirected to your database once it is ready. So if we compare the pricing structure between Cloud Data Store and Cloud Bigtable, always remember Cloud Data Store, you pay for monthly storage, which is also in the case of Bigtable. However, here you are paying for monthly storage for reads and writes. But in case of Bigtable, you are paying for cluster when it is running. So Cloud Data Store is a good option for small data, infrequent access, and it acts cheaper. When you talk about large amount of data or big data and frequent access, then you're talking about Cloud Bigtable. So Bigtable is cheaper when you talk about larger amount of data. So here it says, since your database is empty, you can still switch to Cloud Firestore in native mode to get more features. You could do that. You could learn. You could say query by GQL. As of now, we don't have any data here. Let's look at the dashboard, which says since your database is empty, you can still switch to Cloud Firestore in native mode to get more features. So this is your Cloud Data Store, and it has many features which help you to work with your data. However, some features or important features of RDBMS were still missing, and that's where Google created yet another Bigtable based service called Cloud Spanner. Now we can continue working on Cloud Data Store, which basically gives you one option to work with your data. You can create an entity here by clicking on create entity, and that basically gives you options such as default namespace. You can give a kind, you can give numeric ID, and you can start adding properties. But to learn more about data store, we will learn about this in further sessions. So as of now, I'm going to click on cancel. I'm going to go back to my data store, and this basically, let's go to data store option, or I can go into admin here, which basically says if you have entities, you can import or export them. So let's go back and let's again look into storage options. So as of now, we were in data store. Let's click on this one. So as I mentioned, your Cloud Data Store, which basically gives you some additional features on top of your Bigtable. But what Google also did was it realized that there was a need for RDBMS feature support. That is, there were a lot of features. Now here we have created a data store and it says your database is ready to go. Just add data. You can create entities, start putting in data, and then you can go ahead and query this. So if you would want to learn more about your data store, you can just click on this one, and that takes you to the complete documentation of native mode and data store mode. What is Firestore in native mode? What is in data store mode? What are pricing and locations? How you choose a database mode? What are the feature comparisons, what you can do, what you are allowed to do here, what programming languages can be used, different regions, pricing, and so on. As of now, we'll click on this one and let's look at one advanced service which Google Cloud came up with when it comes to your additional features of RDBMS. So Google created yet another big table-based service called Cloud Spanner. Now that you might not see here, but if you scroll down, you should be able to see your Cloud Spanner in the options here. Or did we miss it on the top? So let's again look here. Yeah, so it is here and you can click on Spanner. So Cloud Spanner was released in 2017. It basically supports relational schema. So it offers strong consistency for all queries, which can be SQL based. You can have multi-region deployment. Now, when it comes to massive scalability requirement and strong consistency, Cloud Spanner is a good option. So it says Cloud Spanner is a managed, mission critical, globally consistent and scalable relational database. So if you would want to use this, then you will have to enable this API, which shows you an option here. It says try this API. So it's a managed service. So it is one of the Google's most expensive database services. There is also one more database service, which is Cloud SQL, which can be used. So when we talk about your Cloud Spanner, it is fully managed relational database service. It is massively distributed. You can have millions of machines across hundreds of data centers with support automatic sharding and synchronous replication. It gives you low latency and schema updates without downtime, making data high availability and reliability. So we'll learn about Cloud Spanner with more details later in other sessions. Now, we can also go back to storage and we can look at the different options which we have here. So you have object storage, you have Spanner, you also have your SQL based service, which is yet another managed service offered by Cloud or Google Cloud, I would say. So that's called Cloud SQL. So this is basically a service which allows you to have fully managed relational MySQL, Postgres, and SQL Server databases. Google handles replication, patch management, database management, and other things which are related to this managed or fully managed database service. It can allow you to handle terabytes of storage capacity with 40,000 IOPS with huge amount of RAM per instance. So you can click on create instance here and then you can choose one of the database which you would want to use. So Cloud SQL is a managed service. You can choose one of your MySQL or Postgres and SQL Server. Say for example, I choose MySQL. Now that basically tells me what is the instance ID. It sets up a password. You can always change the password. You can change the region. You can choose your database version. And then you can also look at other configuration options which talk about machine type, which will be used, what is about your backup and recovery, maintenance, and all that. And if you click on create, this will basically create a fully managed SQL service, which can allow you to straight away start using MySQL on cloud, thus allowing you to store your relational data. When we talk about storage options, how can we not talk about a data warehouse solution or basically an option which allows you to run your queries by directly updating data? So you can use a data warehouse service which Google Cloud Platform offers, and that's called BigQuery. So basically you can be looking into the big data section here, and here you have an option called BigQuery. So this basically brings ease of implementation and speed. So building your own data warehouse can be expensive, time consuming, and difficult to scale. So with BigQuery, you just load data and pay only for what you use. So when it comes to features, you have features such as capability to process billions of rows in seconds. And if you would want to do real-time analysis of streaming data, that is also possible here. So here we have clicked on BigQuery, which basically shows you the option where you can start typing your query and test your data access. For example, if I have uploaded some data, so it shows me there are some queries which are saved here. Now I can schedule a query. I can basically choose the format of a particular query by clicking on this more. Here I have an option which says add data. So I can pin it to a particular project. I can explore public data sets. I can create a connection. So if I click on explore public data sets, then it takes me to a page from where you can get different kind of data sets which are already available, which you can put into your BigQuery and start querying your data. By default, it shows that it is aligned to my project and I don't need to worry about it. I can look at saved queries if I have already saved a particular query. I can look at job history. I can look at transfers, scheduled queries, and reservations. So BigQuery basically initially had its own version of SQL, which was slightly different from standard SQL. But in 2016, BigQuery 2 was released that supports SQL 2011 standard. You can always select standard SQL. Now, BigQuery, when it comes to pricing, we need to remember that the storage cost is very less here, approximately 0.02 cents per GB per month. It is almost similar to Nearline, where you can also have low cost, that is 0.01 cents per gigabyte per month. There is no charge for reading data from storage. When it comes to querying, and that's where the cost is incurred. So 1 terabyte per month is free, and after that it costs few cents per gigabyte. So this is mainly for high volume customers. There is a flat rate pricing which can be used. So when you talk about querying, you can save your query results. You can create data set to store the results. Now results are put in a temp table in cache. And after you're done with that, you can delete data set and delete all the data. So when you talk about loading data into BigQuery, you can get the data from cloud storage, Google Drive, Cloud Data Store, Stack Driver, Stack Driver, other options. You have Cloud Bigtable or other web interfaces. So you can download from URL such as CSV, JSON, Avro. You can create dataset, create table, and create from source by doing a file upload. So 10 megabyte or less files can be uploaded using web interface. As an option, you can also use command line, and then you can start working with your BigQuery. So here you can also work with streaming data by basically pushing in streaming data into your BigQuery, which allows you to add one record at a time. Now you could use something like Cloud Data Flow, which allows you to use a particular pipeline. About Cloud Data Flow, we will learn later. So you can benefit from different features of BigQuery and thus use Google's offering to work on your structured data, or I would say data which suits well in data warehouses. Now, these are some of the storage related services which Google Cloud offers. Although we will learn about using BigQuery and running or uploading some data by creating add data set here, by say creating connection or using a public data set. So as of now, I have this. You can also access the command line to work with this, but we will learn in detail about BigQuery in later sessions. Now here, you can scroll down and you also have an option within big data space, and that is your data proc. So when you talk about data proc, this is again a managed service which allows you to run Spark or Hadoop jobs. So especially if you are interested in big data workload. So for big data processing, for machine learning, you can always use Cloud Data Proc. This uses compute engine instances under the hood, but takes care of management of these instances. So it's a layer on top to spin up clusters. It's a managed service. It's cheaper, pay when the jobs are running only. It's fast because it is integrated with other Google Cloud services. You have open source components pre-installed, and Dataproc is integrated with Yarn to make cluster management easier. When you talk about Dataproc, you can click on create cluster, and that basically allows you to set up your cluster by choosing a particular region which you would want to use. For example, I'll choose Europe West 4. Here it tells what kind of machines you would want to use, and by default it has populated as the machine here, which is 4 CPU and 15 gigabyte. Now since you might be using a free account, let's not go for the high-end machine. Let's go for N1 standard 2. and then you can scroll down. It says what is the primary disk, what is the disk type, and this one was for your master machine, that is machine which will have the master processes running. Then you have your worker node configuration, which tells this will be, let's choose a lower end machine, and we can choose how many worker nodes you would have. So it says minimum 2. You can choose the SSDs and their capacity. It talks about yarn cores and yarn memory which will be allocated, and here we have then option of clicking on create. So once you click on create, this will basically spin up a cluster wherein you can straight away start submitting jobs to this. You can basically go ahead, once your cluster is ready, you can go into the cluster, you can submit a job, you can choose a type which is Spark or any other application which you would want to run, and then basically you can use this fully managed service which allows you to run your big data clusters. You can obviously control access via roles or access control list, and you can have access as it is at project level or based on your DataProc cluster or even at your worker nodes. So we'll learn about DataProc in later sessions. So as of now, you see here, the cluster is getting created. It says the cloud storage bucket, which it is using, is this one. Now I can click on this and open link in a new tab. It still takes me into console, but now it is showing me the bucket which is being used by your DataProc cluster. This is the bucket which is being used, and it is being used for underlying metadata which gets stored here. So you look at the cluster related folders, you can click in these folders and then it can see what is the script output, what it is doing, and so on. Now I can come back here to my bucket, which will basically show me what kind of buckets have been created. So you see DataProc service automatically created some buckets which will be holding some data. You also have some other buckets which were created based on other services which we used. The access control is fine-grained in all cases, plus it also shows our bucket. So underlying, it is using compute instances. It is basically using, let's go here and let's go to compute engine and let's look into VM instances. So DataProc, which has spun up a cluster, is also using the VM instances which we see here are running. It is using the buckets and it has made a cluster ready to use. So you can click on this cluster and that shows me my cluster related details, if there are any jobs running, what are VM instances, what kind of configurations it has used, and you can look at different details here. You can look at the logs, you can click on jobs, and that will show you if you have basically run a job on this ready to use cluster. So it says there is this particular job which was run, which was a Spark job. You can click on submit, and this one tells you what is the job ID, what is the region you would choose. For example, we will again choose, for example, Europe West 4. It tells what is the job type. So you can run all these type of jobs in this cluster, such as Hadoop, Spark, PySpark, Hive, Pig, Presto. You can give your jar file. So if you have packaged your application as a jar, you can mention that here. You can pass in some arguments. You can also say some other jar files, add some properties, and then click on submit, which will run your job on this ready to use cluster. Now, since we have tested it, I can basically go ahead and do a delete. I don't want to incur any cost on these managed services which are running. So there are a lot more information about using these services which Google Cloud Platform offers, and we can continue learning about these services as we explore your Google Cloud Console or even your command line option. Now we can come out of this one by clicking on this menu, and then we have other options such as Kubernetes, you have cloud functions, you have your networking related services, monitoring related services, different kind of tools what you have other big data specific services which you can learn about. And for each of these services, Google has a very good documentation available. For example, when you talk about publish subscribe messaging system, it is a real-time managed service which basically is a pioneer which was used, and now you have a famous service such as Kafka, which is being used for your publish, subscribing, or messaging system kind of requirements. So to conclude about Google Cloud Platform services, you can always go to cloud.google.com and look into the document section. Now here you have list of different featured products. You also have list of your different domains and services which Google Cloud offers, and you can learn about all the different services which are offered by Google Cloud. Here you can click on featured products, and that basically shows you Compute Engine, Cloud Run, Cloud Storage. You have Cloud SQL, BigQuery, Vision AI. You can scroll down and look at your artificial intelligence and machine learning related services, platform and accelerators, API management. So Google Cloud Platform offers different services mainly in your compute, storage and databases. You have networking related services, big data specifics, developer tools, cloud AI, identity and security, IoT management tools, API platform, and so on. So basically learn about the GCP services which Google Cloud Platform offers, and in detail you can play around with different services which are offered by creating a free account. And as I demonstrated, you can use any one of these services, quick start them, basically connect to them, put in your data, or use a managed service to manage your data and benefit from Google Cloud Platform, thus having modernized infrastructure for your different use cases.
And with that, we have reached the end of day 4. So far, we have learned the integration and working of DevOps with cloud. On day 5 of DevOps Learning Week, we will reveal the next stage where you get to master the popular DevOps tools. Thanks for watching, and don't forget to subscribe to stay tuned for more from Simply Learn.